Here we are on the notes for 4.11 factoring expressions, and in this note video we will be focusing on factoring using the algorithm. Okay. So we're going to skip this whole first page. We're going to skip actually to page 10. All right, so the page that looks like this, where it says to use the GCF and the distributive property to write equivalent expressions. So the GCF, to remind yourself, is the greatest common factor. So that is what we're going to be using here in order to factor these expressions. So we're going to kind of skip around some of these little individual questions. So if we just look at 3f plus 3g, and for some of you, you could probably figure out the greatest common factor of 3 and 3 just by looking at it. Okay, but some of you might have to write out the factors. Remember, factors are the numbers that multiply to make a certain number. So here would be 1 and 3, 1 and 3. And then we want to use the greatest one, which is 3. So that means that 3 would go on the outside. And now on the inside, it's like dividing each of these by the greatest common factor. We're taking it out, so we would just be left with f plus g. Okay? So if we look at number 2 here, we have 6x plus 9y. So I'm looking at the factors of 6 and the factors of 9. So the factors of 6 would be 1, 1 and 6, and then 2 and 3. The factors of 9 would be 1 and 9, and then 3 and 3. That's what multiplies to make them. And I want to take the biggest one. So between the two lists, my biggest one is 3. So that means 3, my greatest common factor, goes on the outside. And now I'm dividing both of these by 3. So 6 divided by 3 would be 2x plus 9y divided by 3 would be 3y. Okay. And one more on this page here, number 11, or sorry, not number 11, number 3. So we're looking at the numbers 3 and 11. So to make 3, it's only 1 and 3. And for 11, it's only 1 and 11. So our greatest common factor is 1. But really, dividing by 1 doesn't really do anything for us. But if you look here, they both have the letter C. So we can factor out a letter that's common. So C would go on the outside. And then we're just left with 3 plus 11. And you would not add the inside numbers. Okay? So if you flip the page, then we've got some more examples here. 24b plus 8. So I'm looking at 24 and 8. Let's see, factors of 24, all kinds of factors. There's 1 and 24, 2 and 12, 3 and 8, and 6 and 4. Then for 8, we have 1 and 8, and 2 and 4. So between them, the biggest number on both lists would be 8. So that's what I'm going to factor out. So I'm going to divide both of these parts by 8. So 24b divided by 8 is 3b plus 8 divided by 8 is 1. And you'll notice there's no letter on the second part, so I won't put a second letter in my answer. All right, and then we'll just do a few more here. So 7x plus 7y, I think you can kind of see they both have a 7. So 7 would be factored out. So if I divide by 7, I'm just left with x plus y. Now in part B here, I've got 15g and 28. So 15 and 20, let's see, factors of 15. 1, 15, 3 and 5. Factors of 20, 1 and 20, 2 and 10, 4 and 5. So my biggest one would be the 5, so I'm going to factor that out. So I'm going to divide both of these by 5, and I end up with 3g plus 4h. Okay. And let's see, you can cross out C and D are a little excessive. Let's look at part E though. So I have 11 and 15. So 11, 15. Let's see. Factors of 11 we did on the other page. 1 and 11. Factors of 15. 1, 15, 5, and 3. So again, my greatest common factor is 1, but they do both share an f. So I can factor out the f, divide by f, and I end up with 11 plus 15. Okay? So that's all I'll do for now. You'll do some more practice in the classwork. And, some of you won't have to list out the factors. Some of you will need to, and it's okay no matter which way you do it. So that's all I'll do for now, and then we'll do some more practice together in the classwork.